So in this video we will discuss the composition of functions, and basically with the composition of functions we will go through the addition of functions, subtraction of functions, products of functions, and quotients of functions. So first of all, let's just start with adding functions. So basically for adding functions, it becomes, if they give us f plus g of x equals, see, this is what it's going to equal. So it's going to equal basically the function times plus the other function plus g of x. Same thing with the subtraction. You just get f minus g of x equals f of x minus g of x. Now, the most important thing for this over here, the subtraction, is this negative sign. In the end, we're going to have to keep track of it and make sure it distributes into the g of x function. So from there, what we do is we're going to use an example. So if we're given f of x is equal to x squared minus 5x, and g of x is equal to 2x minus 10, then what we have to do here, it says find f minus g of x. So that means basically what we're going to do is we're going to do x squared minus 5x, and on the other side we're going to minus parentheses 2x minus 10. Now it's very important that we keep track of this negative sign in front of the parentheses, because it's going to distribute into the parentheses. So from there, what will happen is we will get x squared minus 7x plus 10, because when we do this, we distribute the negative sign, but our next step is just to combine like terms. And combining like terms is just, you should know it by now, so I'm not going to go over that. But then what we have here is we're going to have products and quotients. So this is the underlying rule that we did. It's going to be f times g. It's important that I use this little dot instead of a circle. X equals basically the function x, f of x times g of x. So now what does this mean? Well, we're just basically multiplying the functions, and then we get our quotients, and it's the same deal. We just put them over each other. So I will not write that. But if we have an example, like let's say f of x is equal to square root of 1 plus x, and g of x is equal to square root of 3 minus x, and they ask us to multiply the functions. Now, so we're just gonna multiply square root of 1 plus x times square root of 3 minus x, and this will pan out to square root of, using the property of radicals, this will turn out to 3 plus 2x minus x squared. So then from there, basically, if for this we just multiplied the functions, and that's all they asked. So, but if they ask us something else, let's say they ask us find h of 2. So if they ask for h of 2, now we know that h of x is supposed to be this function times this function. So when we get this, h of 2 just means, since everywhere you see x in the h that we just got, you're going to plug in 2. So I would just plug in 2 wherever these x's are, and I would get square root of 3. But now we're going to move on to dividing functions, and these for dividing functions, I told you that was very important to factor and simplify, because if we have, let's say we have f of x is equal to x to the third minus 3x squared plus 2x minus 6. So then we have g of x is equal to x minus 3. Now I'm going to do this. I'm going to take this x3 minus 3x to the second plus 2x minus 6 and put it over the x minus 3. Now, what is this basically going to do for me? I'm going to have to eventually factor out, and it's going to simplify. But for now, we look at the bottom and we say, well, if the bottom equals 0, it would be undefined, and it cannot equal 0. So we're going to, x minus 3 equals 0. We set it to 0. And we find that x cannot equal to 3. So that just means that this will be undefined at x equals 3, so it can't even go there. So what we're going to do though now is we're going to factor. So it's going to be x squared x minus 3 plus 2 x minus 3. So then we have that over x minus 3. Now x minus 3 cancel out over here and over here. So it's gonna go over here. Let's go over here, and it would be x squared plus 2. Oops, I did not mean to write a superscript, but plus 2, where x cannot equal 3, and this is our answer over here. So all we did was factor and simplify. So then from here we're going to clear the board, and now we're actually going to go into the actual composition of functions instead of just adding, subtracting, multiplying, dividing. And this is just simple substitution of a function into another. So if they give us f of g, now notice that this should be a open circle, and f of g of x equals f parentheses g parentheses x. Now what does this mean? This means we take this g of x and we're going to plug it into that f wherever we see x. So if they give us, say, f of x is equal to the square root of x plus 3, and g of x is equal to 2x minus 5. So they ask us to do this, the f of g of x of that. So I'm going to rewrite that over here, parentheses g of x. Means I'm going to plug this into here. So I'm taking this g and plugging into that f of x. So it's going to be square root of 2x minus 5 plus 3, which would be square root of 2x minus 2. Now I'm not going to go further with that, but this is exactly what we do. So I mean, if they ask you for maybe this is h of x, and they say find h of 2 of this, or h of any number, you just plug that in wherever you see these x's, and then you get your answer. But if it's composition, and even if they do g of f of x, or something like that, you just, the one in the parentheses, you will plug into the one outside, and then you will simplify from there, and that is your answer. So if you have any questions on the composition of functions, feel free to ask.